With this video that's entitled Optimization Basics, we're going to talk through some of the aspects and concerns, functionalities, tools that you have, basically all things dealing with optimization in general with SQL Server 2012. Now understand this is a deep subject. It's as much art as it is science and as much science as it is art and so forth. So what I want to do here in this video is kind of expose you to the ideas of what we're trying to get to. And then in the next 2 or 3 videos or so, take a look at some of the tools that you can use and how you can use them. The main thing you want to understand going into the exam when it comes to optimization are the tools that you can use and how to use them. So that's what we're going to cover here. Now, every time you execute a query, SQL Server works very hard to go about collecting the data you're requesting in the most efficient way possible. It tries to optimize the process of collecting the data. Now, it does a lot of things, and then when it finally collects the data for you, it exposes its final decision on its optimization efforts to you, and you can get that information in a number of ways. Now, the SQL Server Query Optimizer is what does all this work. Now, you can't point to any one thing in SQL Server and say that little green thing right there is the Query Optimizer. The Query Optimizer is a whole set of functionalities. It's a complex set of algorithms and stuff going on under the hood. We'll just leave it at stuff going on. It usually does a pretty good job. However, properly written queries, good indexes, and so forth make it even better. And this is one of those bleed over areas with SQL Server where to be a good developer, you also have to be a little bit of a good architect and designer. And to be a good designer, you also need to be a good developer and so forth. And it also makes sense that poorly written queries cause problems. Now, the best way to understand optimization is understand the execution phases that happen every time you execute a query. The first one's kind of called the T-SQL stage, then parsing, then binding, then optimization, and then execution. Let's talk a little bit about each one of these. In T-SQL, the statement is accepted and read. In the parsing phase, the syntax is checked. In the binding phase, we're doing name resolution. Do the objects exist? Is the table out there? Does this user have the permissions on this object that he needs? Optimization comes next, where SQL generates, theoretically, every possible execution plan for the query. Now, depending on how complex the query is, the number of execution plans get a lot more numerous, and so we don't get them all. But it starts to look at the different ways that it could go about getting this data, and then it chooses one. Now, it is a cost-based optimizer. It is applying cost to these things, much like we do when we go to Walmart, and we decide what we're willing to pay for what we're going to get. And that's exactly what SQL Server is doing with these queries. Then it executes the query. The query happens, and then the execution plan that it decided on is cached. It's put out there in memory so that if this query comes through again, we could run it again. Now, the optimization and execution phases are really the two most important here. Now, a lot of people could disagree with that statement and be exactly right, because when it gets to syntax and the T-SQL that's submitted, that's a very important phase because a poorly written query is going to be poorly optimized. So, optimization, what's important about this phase is SQL chooses an execution plan based on its findings. When it looks at the query, it looks theoretically at all possible execution options. It chooses the lowest cost plan based on its estimations, and often little things like adding an index or changing the query type or even the structure of the query can have a significant impact on plan estimations and choices. Little decisions of do we do a join query or a subquery? Is there an index in this table? And understand now, this topic of having an index on a table oftentimes is not the developer's opportunity. Okay, that has to go through the DBA or the architect or someone, but still that will make a difference. Then, as far as the execution phase is concerned, the chosen execution plan is cached and can be used again when that, watch these two words here, identical query is executed again. Now, it's kind of rare that you're going to execute the identical query very many times because usually only certain parts of the query are changing. This is going to be like data after the where clause, right? Where last name equals. You're always going to be putting in a different last name there probably. And so SQL Server will try to automatically parameterize those aspects of the query so that if it shows up with the same query but a different value that it's looking for, that it's filtering on, it will see that and parameterize it and call that same execution plan. That sounds good, but the fact is really there's a lot of reasons that plans end up not being reused. And so with a lot of queries, it just simply doesn't happen as often as we'd like. However, stored procedures usually are reused, and this is one of the reasons you always hear about stored procedures being such a cool deal. Now, SQL Server offers 3 main monitoring tools that you can use to optimize your queries or to look and see what SQL's thinking and doing with your queries. The first one, SQL Server Extended Events, then SQL Trace, and SQL Server Profiler. Now, pay close attention to this note. SQL Server Profiler and SQL Trace are going to be removed in a future version of SQL Server, so Microsoft's suggesting that you use Extended Events instead. So go ahead and start getting used to it, okay? So that's the basics on optimization in SQL Server. Now let's move through some of these tools and take a look at them.